Good morning and welcome to Physics Friday. If you're new to this series, click on the link above to see the whole playlist. In the last video, I showed you how to convert a measurement made in one set of units into a different set of units. Today I'm going to introduce you to the International System of Units, or SI units, which is the set of units used by scientists around the world. It's called SI because in French its name is Système International. The International System of Units is based on the metric system, with only a few differences. In the metric system, we have a few base units, such as the meter for length, the gram for mass, the liter for volume, and so on. Then if we need bigger or smaller units, there is a set of prefixes that we can attach to each unit to multiply it by a power of 10. For example, a centimeter is 1/100th of a meter, a kilogram is 1,000 grams, and a milliliter is 1/1000th of a liter. Here is a list of prefixes used in the metric system. Each of them multiplies the base unit by a power of 10. So for example, the prefix kilo, as in kilogram or kilometer, multiplies the base unit by 10 to the third power, which is the same as multiplying by 10 3 times, or multiplying by 1,000. This way, instead of saying 1,000 meters, we can instead say 1 kilometer. We'd write that using a lowercase k for kilo and a lowercase m for meter, km for kilometer. The prefix milli, as in millimeter or milliliter, multiplies the base unit by 10 to the power of -3, which is like dividing by 10 3 times or dividing by 1,000. So instead of saying 1/1000th of a meter, we can say 1 millimeter. We write that using a lowercase m for milli and another lowercase m for meter, mm for millimeter. For this course, the prefixes we'll use most often are kilo, centi, and milli. You should remember the meaning of each of those. As for the rest, it's easy enough to look them up if you need to, so I wouldn't suggest memorizing the whole list unless you enjoy that sort of thing. Now the main idea behind the international system is that there is a set of 7 base units that can be used directly or in combination to measure anything. The SI units are sometimes called MKS units, because the 3 base units that are used most often are the meter for length, the kilogram for mass, and the second for time. So if we're measuring length, we'd want to convert all measurements to meters. Measuring mass, we'd want to convert to kilograms, and measuring time, we'd want to convert to seconds. The other base units in SI are the Kelvin for temperature, the ampere or amp for electric current, the mole for amount of a substance, and the candela for luminous intensity. Now, there are more than 7 types of things that we need to measure in science. So how do we do that in SI units? The trick is using the units in combinations. So for example, if we wanted to measure an area, we could use meters times meters, or square meters, which we'd write as meters squared. If we wanted to measure a volume, we'd use cubic meters, or meters to the third power. If we wanted to measure a speed, that's just how far something moves in a certain amount of time. Well, the unit for length or distance is meters, and the unit for time is seconds, so we'd use meters per second, or meters divided by seconds. Now, some things require a lot of base units to measure this way. For example, if we wanted to measure a force, force is what it takes to accelerate a certain mass to a certain speed in a certain amount of time, and the units work out to be kilograms times meters per second per second. Rather than write that whole thing out over and over, we use what's called a derived unit, the Newton. 1 Newton is defined as the force required to accelerate 1 kilogram of mass by a speed of 1 meter per second every second, so that all we have to write is a capital N instead of all those base units. This becomes important when we measure things like energy and power, which require even more base units to write out in full. Instead, we can use the SI derived unit, the joule, to measure energy, and the SI derived unit, the watt, to measure power. So let's try some examples. Hoover Dam has a maximum power of 2,000 megawatts. What is this in watts? Well, looking at our chart, we see that the prefix mega means 10 to the power of 6, or 1 million. So 2,000 megawatts is 2,000 times 1 million watts, or 2 billion watts. Now, we have a prefix for a billion, giga, so we could also say that it's equal to 2 gigawatts. The thickness of a human hair varies a lot, but let's say we measured one to be 0.1 millimeters thick. What's that in meters? What is it in micrometers? Well, the prefix milli means 10 to the power of -3, or 1/1000th. So 0.1 millimeters is 0.1 times 0.001 meters, or 0.0001 meters. What about micrometers? Well, 1 micrometer is 10 to the -6 meters, or 0.000001 meters. We can use this equation to make a conversion factor like we discussed in the last video in this series. Link above. We can write 0.0001 meters equals 0.0001 meters times 1 micrometer over 0.000001 meters. The meters cancel out and we're left with 0.0001 divided by 0.000001 micrometers equals 100 micrometers. Now it's your turn to try. As usual, I'll put all the answers in the video description. The distance from New York to Los Angeles by air is 3,944 kilometers. How far is that in meters? How far is that in megameters? Computers using the Unix operating system measure time as the number of seconds since the beginning of the year 1970. As I'm writing this, I note the time is approximately 1,596,000,000 seconds. Express this amount of time using metric prefixes. A car's engine has a power output of 200 horsepower. What is this in watts? What is this in kilowatts? You'll need to convert using the equation 1 horsepower equals 746 watts. If you want to see more videos like this, subscribe to my channel, or click on the link to the whole Project Physics course, or to the next video in this series, which is on using scientific notation to write very large and very small numbers compactly. As always, if you have any problems or concerns, let me know in the comments. Until then, class dismissed.